Welcome to tutorial 12. In this tutorial we're going to look at circuit symbols, identification of circuit symbols. Some of these symbols are of devices that we haven't studied yet, but for the time being we'll just deal with learning what the symbol is and basically what it does. The only symbols I'll be going through is the ones that you definitely need to know. There is in the document folder on your CD-ROM or CD a file called Circuit Symbols PDF, which gives you all the common circuit symbols. I wouldn't waste too much time on those. Basically concentrate on the circuit symbols in this tutorial and you'll be fine for your standard amateur radio assessment. We're going to go straight into the sample exam questions, as in this tutorial we're just doing symbol identification. However, I will tell you a little bit about the symbol and later on in the course we'll be learning much more about it. This is the symbol of a semiconductor diode. A semiconductor diode will only conduct current in one direction against the direction. See this arrow? Current, if you wanted current to flow, you must make current flow against the direction of the arrow. That is, from left to right, against the direction of the arrow. This symbol on the diode is the cathode. This symbol is the anode. Diodes only conduct from cathode to anode, so from left to right. You'd have to put negative here, positive there, to forward bias this diode. Diodes will only conduct current in one direction only, from negative to positive. Therefore, one of the good applications for diodes is to convert AC into pulsating DC. Question 9.2. This symbol is a Zener diode. Zener diodes are used as voltage regulators. Zener diodes also have a cathode and an anode, but Zener diodes are always reverse biased to the point where they conduct. If you reverse bias a diode, it will not conduct normally. However, Zener diodes are made to be able to make them conduct easily in the reverse direction. This would normally destroy a diode, so a resistor is always placed in series with the Zener to prevent that. And what Zeners do for us is provide a constant voltage across the Zener. So it's a voltage regulator. Question 9.3. This symbol represents a varactor diode. A varactor diode is also a reverse bias diode, the same as the Zener. So this is the cathode, this is the anode. Positive would go on to the cathode and negative would go on to the anode, and that makes the diode non-conducting or reverse biased. What a varicap diode does for us is provide a voltage variable capacitance. By changing the reverse bias on a Zener diode, we can change its capacitance. So if that Zener diode, for example, was in series with a quartz crystal in an oscillator, by changing the reverse bias on the diode, you change its capacitance, and that would slightly change the crystal frequency for us. That's just one application of a Zener diode. Of a varicap diode. Oh, I've marked light emitting diode. Oops, sorry about that, folks. I meant to mark varicap diode. Hope I didn't confuse you there. This is a varicap diode. It's a voltage variable capacitor. So wherever you need a capacitance and you need to vary that capacitance with a voltage, rather than have a shaft or variable capacitor, we can have an electronic variable capacitor called a varactor or varicap diode. Always reverse biased. Question 9.4, this symbol here is that of a light emitting diode. All semiconductor diodes emit light. Even diodes that aren't built in coloured plastic cases emit light. If a diode is a power diode in a black case, it will still emit electromagnetic radiation, however it won't be in the visible spectrum. Light emitting diodes emit light in the visible spectrum. So you can get blue, red, white, green, yellow, etc. Light emitting diodes, in order to emit light, must be forward biased. So negative would be on the cathode, positive would be on the anode, and for a typical low power light emitting diode, the amount of current required to turn a diode on is around about 20 milliamps. You just need to remember the symbol of a light emitting diode, and the arrows are the light coming from the diode. Question 9.5, again, just asking for the identification of the symbol. This symbol is a valve, and it's a triode valve because it has an anode, a control grid, and a cathode. This is the heater. The heater heats the cathode to boil electrons off. The heater is not considered to be an element of the triode. So this is a triode valve because tri means three, and we have three electrodes: anode, control grid, and cathode. A triode valve is an amplifier. If we want to amplify a signal, we send it to the control grid, and the amplified signal appears in the output circuit. So input signal is to the control grid, output signal amplified is between anode and cathode. For now, you just need to know the symbol. I should mark that for you. It is a triode. Wouldn't worry too much else about vacuum tubes at this stage. Question 9.6. This symbol is of a field effect transistor. This terminal is called the drain. This terminal is called the source. This terminal is called the gate. There are two types of field effect transistor, N channel and P channel. When the arrow is pointing inwards into the circle, it is an N channel. I'm going to mark that. It's an N channel field effect transistor. Gate, drain, source. It is also an amplifier. It's a better amplifier than the triode. It requires less power. It's a semiconductor device, not a vacuum tube. The signal to be amplified is fed to the gate. The amplified signal appears between the source and the drain. Question 9.7. It's again a field effect transistor, exactly the same as question 6, except you'll notice the arrow is pointing outwards now. That makes it a P-channel field effect transistor. It's an amplifier, the same as the N-channel FET. The signal to be amplified is fed to the gate, and the amplified signal appears in the output circuit between the drain and the source. This is source, this is drain. The amplified signal appears here. Arrow pointing out is P-channel. Arrow pointing in is an N-channel FET. Question 9.8. This symbol is that of a PNP field effect transistor. Sorry, a PNP bipolar transistor. I'll mark that. The easiest way to remember whether they're PNP or NPN is the arrow. And if you remember that NPN, the arrow is pointing outwards. And NPN stands for never points in. So the NPN transistor, the arrow points outward, never points in. However, this is a PNP with the arrow pointing in. The transistor is also an amplifier. This terminal is called the base, this terminal the collector, and this one the emitter. Base, emitter, collector. By changing the current with a signal between base and emitter, we get an amplified current between collector and emitter. So the input signal again is to the base, which causes a change in current between base and emitter, a very small change in current, and that is amplified in a very large change of current in the emitter collector circuit. Same as the last question, except this is now an NPN transistor. NPN stands for, it doesn't really stand for this is to help you remember it. NPN never points in, the arrow never points in on an NPN. So arrow pointing out, that's an NPN transistor. Again, base, emitter, collector. The emitter is always the one with the arrow on it. Base, collector, emitter. An NPN transistor. Question 9.10 is asking about the arrow on the symbol. This symbol, the arrow is pointing out, so this is never points in. This is an NPN transistor, and the arrowhead is the emitter. So this terminal is the emitter. This is the base, this is the collector. Question 9.9. This symbol represents, it's a quartz crystal. Quartz crystals are better than LC circuits. With an LC circuit, the resonant frequency is determined by FR equals 1 over 2 pi root LC. However, quartz crystals can be made to vibrate at radio frequencies as well. They're called piezoelectric crystals, and they're far more stable than LC circuits. So if you want real frequency to stability, it's a quartz crystal oscillator rather than an LC circuit oscillator you would use. But for now, you just need to know what the symbol is for. This symbol in question 9.11 is a ferrite cord transformer. It's ferrite cord, it's a transformer, I think you would probably realize that. It's ferrite cord because of the dashed symbol in between the primary and the secondary. This is the primary, this is the secondary. These dashed lines indicate a ferrite core. If they were solid lines, it could be an iron core or a laminated iron core. If it were air core, there would be no lines in the symbol at all. It's certainly not a low-pass filter. That is the symbol of a ferrite cord transformer. Well, that's it for circuit symbols. Not very many at all, really. Now, if you want to look at more circuit symbols, look in the document folder of your DVD or CD, and you'll find a file called circuitsymbols.pdf. Don't get bogged down with trying to remember all the symbols. Just remember the symbols in these tutorials and keep focused on your course, and try not to get sidetracked onto tangents. Otherwise, you'll just extend the length of your course and this course is really designed to be done quickly and to get you through that exam as quickly as possible on theory and regulations. Thank you for listening to tutorial 12 on circuit symbols. I'll see you next time. This is Ron, tt12. Cheers for now.